Algebra 1 Lesson 39, we are using the distributive property to simplify rational expressions. So first off, a rational expression, we are talking about basically our expressions that have variables in the denominator. So we have our fractions and we have our variables in the denominator. And we want to make sure that the denominator never equals 0. So we're going to have some restrictions on here to make sure that that doesn't happen, saying this variable cannot equal 0 or this one can't, and so on. So if we have this expression where we say x squared over y squared times the quantity, x squared over y plus 3y cubed over m. Well, just like we normally do, we're going to distribute all the way out. But to do that, we are going to have to multiply the numerator by the numerator, denominator by denominator, which means, I'll write this out this first time, we're going to do x squared, y squared times my x squared over y, and then add x squared over y squared times 3y cubed over m. And so we can simplify some things and say we get x to the fourth over y to the third, plus, well, I know that I can simplify some of these y's and say, okay, if I have 2 y's down here, 3 up here, I'm just going to be left with 1 in the numerator. And we get x squared, or sorry, 3x squared y over m. Now we have to say if there's any restrictions. So we say, okay, we have 3 variables, x, y, and m. X can be anything because it's not in the denominator of any of my fractions, so we can have it as any number. But y, since we don't want the denominator to be 0 ever, we're going to say that y cannot be 0 because right here we have y to the third, so if we had y as 0, that would make an untrue statement, something that's undefined. And same thing, m cannot equal 0, just like that other denominator. Okay, so this lesson is just going to be a bunch of different examples of what's going on here. So let me try one that we didn't do in class, like this one. Okay, we're going to distribute out, and we are going to say I get a m p x over m, or k m z, minus, and we have this over 1, so we're going to say we get 2m to the fifth p to the fourth over z. And I'm going to see if there's anything I can simplify, and I can, especially in this first term. We can simplify the m's, and it looks like that's it. So we have apx over kz minus 2m to the fifth p to the fourth over z. And so we have 2 variables that we have to have restrictions, so we say k cannot equal 0 and z cannot equal 0. These are part of our answer to say both the simplified version and our restrictions. All right, let's try this one. We're going to expand out, and we're going to say I get dm x squared y over a c squared x squared. We'll simplify in a second. Minus, okay, this is over 1, so we get 2x to the fifth y over c squared. That second term doesn't have anything I can simplify, but I can simplify my x squareds in the first one, and so I get dmy over ac squared minus 2x to the fifth y over c squared. And I have a couple of restrictions. I'll have to say that a cannot equal 0 and c cannot equal 0. Now, you may wonder, well, can't we do something and simplify these? The c squared and the c squared as our denominators? And we would have to say no, because we do not have common denominators. We could get there, but it's not necessary. All right, let's try this one. Now we're looking at some things that have negative exponents. That's okay. I'm going to distribute first and then simplify those negative exponents. So I get x to the fourth over y to the negative second. Remember, when we're multiplying, we add. We have a 1 here. Minus 3x squared y z to the negative second over x y. And let's make sure that we get rid of all negative exponents and simplify any variables we have in common. So we're going to move this to the numerator and get x to the fourth y squared, no denominator, minus, okay, and then I can simplify my x's because I have x in the denominator, x squared in the numerator. Those are going to cancel, and I'm just going to get a 3x. And the y's can also, let's see, we have y to the, let's see, let me erase this to make sure. We have y to the negative third in the denominator here. It didn't show up. So we're going to have to do a couple things. One, we're going to have to move this to the numerator and move our z to the negative second to the denominator. So we have y to the fourth, because we add it to that top y, over z squared. Now we just have one restriction: z cannot be 0. Okay? So make sure you get rid of all negative exponents and simplify any different similar variables that we have. Let's just keep practicing. So now another way that you could do these is simplifying the negative exponents first, so that we have all positive exponents that we multiply then together. So I'm going to do that in this one and say we have 1 over a b. I'm going to move that a to the denominator. And inside we have, well, I'm going to move this a up and the c up. So I have 3a squared b c to the fourth m over, well, there's just a d left now, and then plus, I'm going to move all of these to the denominator, 1 over a cubed c to the fourth. Now, when I multiply out, I'm going to see that I get 3a squared bc to the fourth m over a b d plus 1 over a to the fourth b c to the fourth. And then I just have to simplify. And I see that in the first term I need to do some simplifying with my b's and my a's. So I get 3a c to the fourth m over d plus 1 over a to the fourth b c to the fourth. Now I'm going to have a bunch of different exclusions here. We're going to say that we have restrictions on a, b, c, and d cannot be 0. Because those are all in my denominator that cannot be 0. Alright, let's try this one. We're going to multiply out. We're going to have 3 different terms in this one, and we're going to get a squared, b squared, x over c to the third. Oops, sorry about that. Let me just erase a little bit so it doesn't get too messy. Let's try that again. A squared. Wow, it really wants to go down there. That's okay. B squared x over c to the third. Well, we'll just have to roll with it. Plus 2ab squared x over c squared. And then minus 4ab over c to the fourth. And when I look at this, I don't have anything to simplify. So I just have to say that c cannot equal 0. Okay? And because we don't have like denominators, I can't add these together. We'll just do a couple more practices of this. Let's see. I'll try this one with those negative exponents again. So I am going to move my exponents first in this one. Okay, it doesn't matter, we could multiply out and then move them, but in this one, let's move them, and I will get mp squared over n to the fourth on the outside, and then I'm going to have rn over m squared p minus n to the fourth over r squared plus 8m over p. Now that I'm working with all positive exponents, I just multiply out, and I get mnrp squared over n to the fourth m squared p minus n to the fourth mp squared over r squared n to the fourth plus 8m squared p squared over n to the fourth p. And there's some things that we can simplify here. Let's go term by term. And in the first I see some n's in common, m's in common, and p's in common. So I can simplify, and I'll get rid of some of these. So I'm going to get rp in the numerator, and then I'm going to get n to the third in the denominator. I believe that's all I'm going to get. Let me just check my work. That looks right. And then minus, well, we have some n to the fourths in common, so those actually cancel out completely. And I get mp squared over r squared. And then plus, my p's can simplify a little bit, so I get 8m squared p over n to the fourth. And I have a couple restrictions. N cannot be 0, and r cannot be 0. Okay, so you probably start to see a pattern. We multiply out, we simplify as much as possible, and then we say some restrictions. Here are a couple more examples for you to work out on your own. Just remember, it's up to you as far as negative exponents if you want to move them first or deal with the negatives and then move them while you are simplifying. Well, I hope this is helpful for your homework and for studying.